let's get started. I want to talk to you about Layer 2 off-chain payment solutions. You might have heard that Bitcoin and similar protocols based on Nakamoto consensus have an inherent scaling bottleneck. We know that Bitcoin itself is minting 1 megabytes every 10 minutes. That limits the amount of space on the blockchain, and that limits what you can do. So one solution, of course, is to move the payments out of the blockchain into what are known as off-chain payments, also known as Layer 2 payments. So this is a good idea, except the current solutions for doing so, mostly centered around Lightning Network, require the underlying blockchain to be free of malleability, or they require their conjectures that perhaps Lightning could not require this, but then it gets very cumbersome and the protocol becomes slower and much more complex. What I'm going to show you is something called Teechain, and it doesn't suffer from this, and it has a bunch of other advantages over Lightning. So this we see as the future of off-chain payments on top of blockchains. So this is going to be a homegrown demo. It's not going to be as slick as Warhes's very nicely produced video. What I have set up for you here are 3 servers. This one on the very left is in the UK. We're going to call it Alice. The one in the middle is at Cornell in the US. So there's the Atlantic link between the two. And the third one is also in the UK. Okay, so that's Carol. So Alice, Bob, and Carol. And the fourth thing down there is also Carol. It's another window at Carol's facility. Okay? So what I did ahead of time to keep, because I have such little time, is I started Teechain on all of these machines and got the servers started. So what I'd like to do next is tell Bob's machine to expect to create channels. So that's going to try to create 2 channels, one with Alice, one with Carol. And so you can see here perhaps that Bob is trying to create his channel. And on the left, we will start Alice's channel. Alice create channel. And we're going to see how long that takes. 2 Mississippi, 3, 4, okay, 5 Mississippi. So it's like 5 seconds, it says, to create a channel between this guy and that guy. We have a transatlantic payment channel now. Let me get started on the Carol side. So here we go, not this. Carol. If I could only type Carol, create channel with Bob. So we're going to spend about 5 seconds creating that channel. So once the channel is established, some outputs are taken off of the main chain and into the secure hardware enclaves running on these machines. The thing that makes our solution different from the existing software-based solutions is that we use secure hardware. So these machines are Intel machines purchased off of the internet. Most recent Intel consumer devices come with secure extensions, and that's what we're taking advantage of. The machines cost, just like my laptop, they cost exactly the same as any other laptop. The extensions are right there, already usable. So, okay, so we've established the channel there, and the channel on the other side, we're watching the logs. This is a good time for Alice to send Bob some money, and we have a script to do so. What is it, Alice send money or something? Send to Bob, and that was a send operation from Alice from the UK to the US, and the US node said I received 1 Satoshi. There were no fees. It just happened, and so I can do this again and again. Let's see, why is it not? Yep, there we go. Here we go. That was pretty fast. Just how fast is it? I don't know. Let's measure it. Alice, many sends or something like that. There we go. Alice is doing 100,000 send operations for 1 Satoshi each. And that ended, that said about 15,000 transactions per second. When I ran this before outside, it was 50,000. So, okay, well anyway, so that's what it is. I suspect that it's because of the scrolling, actually, that's what's keeping us slow. So if we were to get rid of the logging, and if we were to not log onto a slow machine like this, we would go much faster. So that's that. That's kind of cool. But you might worry about things like, well, what happens to my funds if my machine fails? Let me demonstrate that. So on Carol, let's say, we want to, before I show that, let's see. Let me actually do something else, which is kind of cool. Let me show you, I'm showing you the Carol log. Let's go back, I deviated from the script here. Let's have a send operation to Carol. So now I'm going to send some funds from Ellis to Bob to Carol. Carol just received 50 Satoshi through Bob. You remember that Alice and Carol don't have a connection between them. They don't have a channel. They ended up routing the money. It took 2 seconds for this 2-hop send operation. It was painless. It was easy. And it happened without any concern for malleability. SegWit is blocked. It may or may not ever activate. If it doesn't matter. Nothing in our protocol is vulnerable to it. This can work today. So that's so far so good, but you might worry about things like, well, what happens when my machine fails? Let's suppose Carol is that kind of a person and is very, very concerned. So what she can do and say is to say, well, is to say, hey, I would like a backup. And then over here, she says, okay, bring up the backup. So now whoa, no. Okay, so clearly this was a failure. Okay, well, I'm going to have to skip this portion of the demo. Instead of trying to sort of bring this up at the moment, I'm not sure what happened with this node. I actually did not do everything on this one that I should have done clearly on the other that I did on the other nodes. But what you would have seen is you would have seen that this node becomes a slave to that node. And the money sends happen just as before, except when money is sent, both the primary and the backup get updated. And should something happen to the primary, then the backup generates the settlement transaction. That was going to be the next maybe couple minutes of the demo. So I think what I'm going to do is stop this right now and maybe try to restart it while I take questions. And that's maybe this most, let's see. So what are the concerns that people might have with this? So the concerns that some people raised when we first came up with the Teechain idea were that, well, you are presenting numbers here that don't deal with actual, they don't take into account fault tolerance. Well, we now take into account, we actually provide full fault tolerance. You can actually create as many of these backups as you like, and the backup process is secure. Second issue that a lot of people have to worry about in the off-chain payment business is the atomicity of transactions. What happens if you're going over n hops and one of the hops along the path fails? Our protocol ensures that you're always in a consistent state. Money never gets lost. It's never lost or stuck in between. You are never affected because of, you never lose funds because of the failure of a node in the middle. Either the money never leaves, or the money actually gets to its destination, and the channel is always in a consistent state. There is never any intermediate, complicated situation where your customer is going to call you and say, I was sending some money, it looks like it went part way, but it didn't complete. Then you never have to get in touch with the route operator in the middle. That is not a concern for this. And finally, some people are worried about SGX being essentially, some people who are kind of clueless have claimed that SGX is a pipe dream, doesn't exist, you can't get keys and so forth. That is not true. We have signing keys, and our enclaves are signed. And should a hacker break into your machine, change the enclave, change the code to steal the funds, it is not a problem at all, because then the channels will not form. Unless the code retains its integrity, then the enclaves will not get started, and we will not have connections form. Another concern that some people might have is, well, what happens, aren't you then making us dependent on Intel? The answer is no. There is nothing about this technology that I demonstrated that is specific to Intel. The protocol can be made to run on any T, and any secure hardware platform can be made to communicate with any other secure hardware platform. And there are many others who are actually looking into this. So we're talking to various different people who are excited about taking this technology and deploying it on a wide variety of secure hardware platforms. So with that, I'll take questions, and I'll try to bring this guy up. Yes?
Sure. So I guess it's very paranoid, but I guess this space has got a very healthy level of paranoia. So if Intel itself was compromised, or the IC design was compromised,
Right.
is that correct?
Depends on the compromise. What does it mean for Intel to be compromised? So, so first of all, like let's actually put some numbers, right? So security is always a numbers and dollars game. And the big question that we should ask here is, what does Intel have at stake? And Intel has approximately $56 billion per year. So would somebody at Intel try to steal the whatever, the few 100,000 in your payment channel? Unlikely. What if it gets it? Yeah, okay. If it were actually compromised, then what they can do is they can try to fool you that somebody with whom you have a trust relationship, somebody with whom you have a payment channel, not a trust relationship, but a payment channel, is not who they are. That is, they're running on an insecure platform, but Intel can pretend that they're running on a secure platform and violate the invariance of the protocol. That can happen. So there are two things that need to go wrong. Intel needs to be compromised, and you have to establish a payment channel with somebody who's going to steal your funds. And then the next question after that is, well, then can you not seek remedies? Yeah, you can seek remedies for that. And you have to also worry about what are the actual probabilities of two compromises at two different providers happening. Good question. Thank you. Yes? So the question is, are there any fees accumulated for ferrying payments along the way? There is nothing in our current implementation right now that does that, but it's trivial to add. We wanted to show people how fast this could be, how easy it could be, and how cheap it could make transfers, off-chain transfers. But it's trivial to add some fees. There are people who are altruistic. There are people who are engaged in essentially consortia or setups where they want to, the five of us want to ferry money and settle at the end of the day every day. 5 of us being 5 big exchanges. So that could be a pretty decent scenario. But if your use case, involves monetization and incentivization, it's trivial to add fees. Go ahead. Is there another question?
I was just going to say, this might be more of a lightning question in general, but how does it scale when you have an increasing number of participants? Because I guess your netting only works when you've got a small number of nodes, if I understand correctly.
Right. So that's a very good question. So how well can you scale Bitcoin with off-chain payments? And I am actually not a big sort of a proponent of off-chain payments for everyone. I think that the extent to which we get benefits depends on an emergent network. What is the shape of that network is one question. What's the capacity of that network? And the answer is nobody really knows. So for me to come up with any number here, I'd be BSing you. And for the people who are pushing this off-chain payments really hard, they are going out on a limb, and they're making a set of assumptions that they haven't even bothered to enunciate, saying that this is going to save the world. So I don't know if it will. I think this is a great technology. I think it's usable in cases where people decide, hey, this could actually help me and my friend connect and settle, and we exchange a lot of Bitcoin very frequently. Those cases we handle. And as an academic, I think I have an allegiance to higher truth. So if I were to say anything other than that, I would not be telling you the truth. Any other questions? Oh, yes, last question.
Yeah, I'm just curious about why the hardware is necessary. I mean, I feel like you've got a bunch of
Great question.
smart researchers in your lab. If we came to those researchers and we said, try to build something just as good as Teechain, but without using secure hardware, is it really not the case that they would do it?
I don't have an impossibility. So the question is secure hardware really necessary here? And the answer is, I don't know if it is, but there's a fundamental difficulty that all software solutions face, which is at any point in time, you and me, the two counterparties, have access to settlement states. And we are ready to settle in our current state. And so what that means is, as time goes on, you are able to settle with a past stale state. And that also means that I have to now watch the blockchain to see if you try to attack me by settling with a stale state. And the hardware allows us to get rid of that attack vector altogether. These payments are entirely off-chain. Maybe I failed to emphasize this. None of these participants were watching the blockchain. They do not need all of that complication that's associated with the Lightning Network. I know the Bitcoin community has sort of been brainwashed into repeating this Lightning mantra, but there are solutions better than Lightning if you're able to make the assumption that you're on secure hardware. And I think you just saw it. Great. Thank you very much. I'll take questions.